Thank you and welcome to the seminar. I certainly appreciate your time. My intent is to present the BICSI Data Center Design Standard and a design scenario in order for you to decide whether or not the 002 2019 standard will be a good design tool for you. Here's a bit more background on myself as it relates to this seminar. As mentioned, I've been an RCDD and a BICSI member since 1995. Up until 1999, I had experience in the data center environment as both a technician and a project manager. In 1999, I became a full-time telecommunications designer and designed my first data center. That facility, I'm happy to report, is still in production. I visited a couple of years ago. Of course, almost everything in it has changed. During that visit, I was reminded of our struggle during the design process to determine exactly what would be the best solution for the client. Of course, 20 years ago seems like 1,000 years in the data center world. At that time, the goal often seemed to be to provide a big cold white room with a lot of electrical plugs. In retrospect, I wish that the BICSI Data Center Design Standard had been available at that time. It certainly would have made the process much easier, much more efficient, and it would have improved the outcome. Use of the 002 standard as a design tool, really a set of tools, by means of today's scenario is what today's presentation goal is. Let me mention that, although I'm a BICSI employee, this web seminar is comprised mostly my experiences and opinions. It does not necessarily represent BICSI approved content. In the hour that we have, it's impossible to deeply and comprehensively examine the content in the BICSI Data Center Design Standard. As part of my job at BICSI, I teach the DC 102 class, which is a week-long data center design course based on the 002 2019 standard. If you are interested in learning about the BICSI Data Center Design Standard, I invite you to take a look at the course. We have successfully migrated the course to a real-time virtual classroom training offering during this pandemic, and students report great success in learning the content of the BICSI 002 2019 Data Center Standard. The course not only examines the standard's content, but also allows attendees to do numerous design activities together in design teams. It's a 5-day, Monday through Friday, online course, and you can find more information on BICSI's website under Education and Certification tab. The release of the ANSI BICSI 002 2019 Data Center Design and Implementation Best Practices Standards is the 4th edition. The first edition was published in 2010. I would be remiss in not mentioning that 2 other documents were released with this most recent 002 standard. Briefly, they are the BICSI 009 2019 Data Center Operations and Maintenance Best Practices. This is for running a data center. The other document is Essentials of Data Center Projects First Edition. This, quote, contains a holistic view of the overall data center project from conceptualization to planning, implementation, and project closeout. Before we get into the design scenario, I'd like to go over some of the initial information from the standard. I think this will be helpful for you to decide whether or not the standard would be a useful tool in your design arsenal. In the 002 standard, right on page 1, it states the standard provides a reference of common terminology and design practice, and that the standard is not intended to be an architect and engineer sole reference or a step-by-step design guide, but may be used to determine design requirements in conjunction with a data center owner, occupant, or consultant. This is typical of industry standards. They aren't intended to be a step-by-step guide, but a collection of tools that we can use to provide our clients with the best solutions. On page 2, section 1.3, which is categories of criteria, the standard states that there are 2 categories of criteria. The first is mandatory, and the second is advisory. The mandatory requirements are our shalls. The advisory or desirable criteria are designated by the word should or similar terms. I think it's important for designers to verify that our clients understand the differences between requirements and recommendations, our shalls and shoulds, and how this applies to various content found in the standard. Our scenario will show some of the differences. Also on page 2, there's a very brief scope section that mentions that the BICSI 002 standards complements other national and global standards. All good standards function this way. So let's jump in the scenario and see how we can use a 002 standard in determining the client's requirements and delivering a standards compliant design. This is sometimes the most difficult part of the design process. Some of my clients are data center owners. Some clients are eager to design and build a new data center, but many of my clients view the data center as a necessary evil that complements and helps their core business, which is not in the data center industry. I have a guest speaker today. My guest speaker will play the role of the data center owner, our client, in the design scenario. So let me introduce the guest speaker. Welcome, and thank you, Dr. McCain. She really is a PhD doctor, a doctor of psychology.
Hello, and you can call me Victoria.
Thanks. I can tell you're going to be a sweetheart client.
You knew that in advance.
Good point. An advantage of the coronavirus work from home situation is that I could persuade Victoria to play the part of a client that is not involved in the data center business. This could represent a type of client many of us design for. Also, I think it's more interesting for you to hear another voice. We're going to use the following design scenario to show just a small part of the information and tools in the 002 design standard. We will start the conversation about designing Dr. McCain's data center for her agency. This agency consists of multiple healthcare facilities spread over several states, offering outpatient and non-surgical settings. The data center will be owned and operated by her organization.
Do I have any other choices besides ownership?
Yes, they're data center outsourcing models.
Is that explained in your design standard?
Yes, it starts in Appendix D on page 477.
We were just on page 2. You skip around a lot.
It's the nature of how standards work.
Good point. What are some of the outsourcing models?
The standard briefly describes managed services model, co-location services model, and several others. I'll show you a decision tree in the standard.
Okay, but we're not going to use any of those.
Not today, but this leads us into a discussion about commissioning at the start of the design process.
I thought commissioning was something at the end of the project.
That's a common belief, but the standard has a commissioning section and it clearly defines roles and responsibilities starting with the pre-design phase of the project.
Can you talk about this phase?
Yep, it's called the program phase, and it establishes the foundation for the other phases and determines the scope of work and the systems to be commissioned. The objectives are called out in the standard. Some of the objectives are establishing the design intent and establishing the project owner's requirements. These are often called BOD and OPR for basis of design and owner's project requirements. We are, of course, limited for time, and commissioning would take many hours to explore, even on a superficial basis. I'll show a couple of screenshots which illustrate some small portions of the robust content about commissioning in the 002 standard. Commissioning is possibly the most important set of processes that ensure operational compliance and project success. And it should start from the first day. Then the standard describes the other phases in a flow chart, which we see on screen. There are individual flow charts for each phase. I'll show you one. This is for pre-design and it's the simplest one. So we'll walk through it. First, on the left is establishing the commissioning team. CX stands for commissioning. The standard also gives a detailed table of commissioning documentation. This table lists the document, who would require the document, who issues it, and who is responsible for approval and revision, and finally who uses the document. I'm showing a very small part of the table on screen.
That looks like it would be helpful. Could one use it as a checklist?
That's a great question.
Well, you did write it.
Good point. Yes, and that's something I talk about in the DC 102 class. Much of the 002 standard can be transformed into checklist and processes if this is something a designer uses.
Who wouldn't use it?
Well, you know how people are.
Yes, I am a psychologist.
Back to our design scenario. In my opinion, some of the best tools in the standard involve setting target goals and expectations of the project. Let's explore some of these. We need to establish the availability class of your data center.
What is availability class?
Descriptions of availability classes are found throughout the standard, but a good place to start is in Appendix B, which is called Reliability and Availability.
That sounds redundant.
Yes, it does, but the standard describes them as different concepts. Availability is designed as a probability that a component or system is in a condition to perform its intended function. Reliability is a probability that a component or a system will perform as intended over a given time period.
Can you give me an example? I'm a healthcare provider, not a nerd.
Let's compare two components. One component breaks once a year and takes 9 hours to restore its function. Another component breaks 3 times a year and it takes 3 hours to restore its function each time. Which is more available? Which is more reliable?
You're asking me?
You bet.
Well, they're both available 8,751 hours of the year.
Whoa, you're not a nerd?
I'm really kind of an actor right now.
Good point. So these components are equally available. Are they equally reliable?
Doesn't really seem so.
Yes, that's correct. One breaks down more. In other words, the time between failure is shorter, so that one is less reliable.
Let me guess, you have a way of calculating this?
Yes, and it starts on page 463 under Reliability Aspects of Availability Planning. And if you come to my DC 102 class, you get to make reliability calculations using the exponential function, also called Euler's number.
Unimaginable fun.
It's pretty fun, except maybe those 5 minutes. So back to your question. The standard describes 5 separate data center availability classes. Each class is defined in terms of 4 areas of concern. Those 4 are component redundancy, system redundancy, quality, and survivability. The classes are numbered 0 through 4. Once the availability class is determined, we can use this for subsequent design decisions. We're guided by the capability of the targeted availability class. Each of the major systems in a data center is described by the appropriate availability class. Examples are telecommunications infrastructure, network, electrical, and mechanical or cooling, and there are others too. Let's get back to the overall classes of the data center and how to determine them. We said we needed a target to aim at. Let's figure out what that is. Per the 002 design manual, this is a 3-step process. So let's walk through it in this scenario. The 3 steps quantify 3 factors. The factors are operational requirements, operational availability, and impact of downtime. For the first step, we will determine with the data center owner the operational requirements. Operational requirements describe the time available for planned maintenance shutdown. So the first question is, how much time is acceptable to take your data center offline for maintenance? We'll look at that in number of hours per year.
I thought data centers never shut down.
That's a common belief, and it's an achievable goal, but it'll take a great deal of both capital expenditure as well as operating expenses.
We would like to keep the costs down.
Let me ask you a couple of questions that may add context. Since a data center will be serving non-surgical outpatient facilities, could it be out of service, say, early on a Sunday for a few hours, would that negatively impact your mission?
Oh, I see what you mean. No, that would be fine. We're not open for business at that time, and nor do we need access to records.
So would this be acceptable once a year, once a month, once a week?
It doesn't really matter. Once a week would be okay.
Well, to put this in definable numbers, say we allocated 4 hours per Sunday. That would be approximately 200 hours per year. Let's see what this represents as your data center's operational level. We can see in the second column that your data center fits in the operational level 1. The 200 hours are between 100 and 400 hours. The description is, quote, functions are operational less than 24 hours a day and less than 7 days a week. Schedule maintenance downtime is available during working hours and off hours. Is that a good description?
We prefer not to shut down during working hours.
Okay, understand. That preference will put you in operational level 3 instead of 1. So we may have to go through this more than once. Data center design, and usually all designs, are a balance of what we want, what we need, and what we can afford. That was the first of the 3-step process. Let's move to step 2 in determining availability class. This step combines step 1 with a maximum annual downtime. This is unplanned interruption of service. Step 1 was planned downtime. At this point, we are starting to do risk assessment. We are balancing the benefit of the data center being in service with the consequence of being out of service. This varies widely between data center owners and the mission of the data center. Step 2 is a determination of the operational availability rating.
I bet you have some questions for me.
You catch on quick.
I am a doctor.
Good point. Here's my question. How much outage can you tolerate? The standard describes this as weighing the cost of downtime versus the cost of mitigating risk and achieving high availability. We will look at this in minutes per year versus the hours per year we talked about in step 1.
Minutes for the whole year?
Yes, minutes for the whole year.
That's a tough question. This data center serves many offices. Each office will have several patients at any one time, so I can't really say.
You have to come up with something. This is your data center.
Hey, I'm the client here.
Well, only until the end of the presentation.
Good point. In a real-world situation, I would prefer no more than 30 minutes per year. We could tolerate that.
And looking at the table, the intersection of operational level 1 with the 30 minutes of annual downtime gives us the operational availability rating of 2. And remember, we spoke about whether or not to have step 1, the operational level, possibly be level 3. On that chart, that intersection puts us at operational availability rating of 3 instead of 2. We'll look at that again in a minute. Now we've moved to the third and the last step. This is classifying the impact of downtime on the mission.
More questions?
Absolutely. We need to determine one of 5 classifications. The classifications describe the impact of unplanned downtime on your data center's mission. These are isolated, minor, major, severe, and catastrophic. The first 2 classifications describe the impact as being local in scope. I don't think these apply because your data center is supporting many offices that are spread over several states.
I agree.
The next classification, which is major, is described as regional in scope, affecting a portion of the enterprise, although not in its entirety, or resulting in moderate disruption or delay in achieving key organizational objectives.
I'm not sure if this applies because a data center outage would affect the whole organization, not just a portion.
Let's keep that in mind. But the second clause of the description does speak about a moderate disruption or delay. Let's look at the next one. Severe is described as multi-regional in scope, affecting a major portion of the enterprise, although not its entirety, or resulting in a major disruption or delay in achieving key organizational objectives.
That might be the best choice for us because even a short outage could cause us to do rescheduling and possibly a long-term loss of income.
Okay, the last one is catastrophic, which is described as affecting the quality of service delivery across the entire enterprise or resulting in significant disruption or delay in achieving key organizational objectives.
The first part of the catastrophic description applies because it will affect the entire organization, but I don't think it will be as significant a disruption as is described here. I'll choose the classification of severe.
So here's the last table in the process, and we see that the intersection of operational availability rating column of 2 with the severe row is class 3. We also spoke about the possibility of choosing availability rating of 3. Per this table, the intersection of availability rating of 3 with the impact of downtime classification of severe also results in the determination of class 3.
So our design target availability is class 3?
Yes, correct.
What exactly does this mean?
The availability class determination will guide us through the design capabilities and the redundancy requirements of all major systems and most subsystems. These capabilities and redundancy requirements are specifically described in the standard. In a few minutes, we'll briefly touch on some of these. The availability class rating not only gives the data center designer consultant a target, but the rich information in the standard gives all of our design partners a roadmap to deliver a data center the client expects. The architect, electrical engineer, mechanical engineer, plumbing engineer, and network engineer will all be guided by the requirements, as well as the recommendations clearly set out in the standard. The way availability class applies to the various systems is focused and unique to each system. But we'll look at the description found in the electrical section. These concepts apply universally. So in this case, F stands for facility. The designator will change by the system. For example, C will be for communications. The 5 classification electrical systems are class F0. It's a single path data center that meets the minimum requirements of the standard, but doesn't meet the requirements of an F1 or higher. Class F1, single path data center. Class F2, single path data center with redundant components. Class F3, the concurrently maintainable and operable data center. And class 4 is the fault tolerant data center. As the number rises, the level of reliability increases. The classes are completely performance related. Single path indicates single points of failure throughout the distribution. If anything fails, then it's very likely the data center will be offline. As redundancy increases, so does reliability. Class 3 indicates there's redundancy of major systems. When a system is offline for reasons of maintenance or failure, the data center will stay in production. The same describes class 4, but when the system is offline, the data center will not become a single path data center. This is the definition of fault tolerant. The concept of availability classes are essential to using this standard, and I think it makes a designer's life much more efficient while delivering a quality design to the client. Now let's discuss the site selection of the data center.
Is this something you do in your class?
Yes, what a great question. Yes, we do.
What's the purpose of talking about site selection? What if the site has already been selected?
There are several purposes, most of which are applicable to a chosen site, as well as setting out parameters and searching for a new site. The second half of the section in the standards address evaluation of utility services. The introduction states, quote, "It is of utmost importance for the data center location to have access to reliable high power quality and high-speed telecommunications services, access to other services such as water, sewage, and other energy sources of conventional, such as natural gas, propane, and diesel, or renewable energy such as wind and solar must be taken into consideration.
Sure, that makes sense. You can't operate a data center without those utilities. What does the first half address?
The first part is evaluating the site specifically using risk assessment of the proposed site.
Yes, we want to avoid risk.
Complete risk avoidance is impossible, but we wish to identify and analyze the threats to our proposed data center site.
Does the standard define risk?
Yes, the overall definition is risk as the product of the probability of occurrence of an event and its impact. There will be events with a very high impact on the operation of the data center, but often those events are unlikely to occur. An example is an airplane crashing into your data center. More common are events that are more probable to occur, but also have less impact.
Can you give examples of some of the events that are outlined in the standard?
Yes, this standard separates hazards into three groups. The first is natural hazards. Examples are geological, meteorological, and biological.
Biological. Would that include COVID-19?
Yes, exactly. I'd like to point out, if this was an actual design meeting...
Actual as in, I get paid for this?
Easy now. If this was actual, you would be paying me for this.
Good point.
Anyway, if this was an actual design meeting, we would use a site selection risk assessment and evaluation in a subsequent meeting about the physical security of your data center, as well as using this information for disaster recovery planning.
What were the three groups again?
As mentioned, the first is natural hazards. The others are human-caused events and technology-caused events. Both of these last two address accidental events as well as intentional ones. Where are you planning on building your new data center? Have you chosen a site?
We haven't chosen a specific site. We would like it in or around Portland, Maine.
The standard requires, quote, "The suitability of a site shall be determined by a site survey and evaluation and a risk analysis." We would do this for several reasons, including determining the suitability and safety of a site. The risk assessment we spoke about would not only help us evaluate risk, but also inform us of any risk mitigation strategies we may take. Also, this would help us gauge the level of risk tolerance your organization has.
Anything else?
Yes, and we'll review some examples, but I'd like to mention that the standard also includes cost evaluation recommendations, which covers one-time capital expenditures such as real estate, environmental studies, and the cost of adequate and redundant utility infrastructures. There are also costs associated with moves and relocation, as well as constructability issues such as permitting and build schedule. Finally, other costs such as recurring costs and intangible costs need to be evaluated, such as utilities, wages, and taxes.
That's pretty comprehensive.
I'm trying to tell you. So, some examples of natural hazards to evaluate the site are seismic and volcanic activity, wildfires, flooding, and wind. Others are ground stability, lightning, and air quality. The standards give recommendation for all of these. So next are human-made hazards. I'll show you part of the table in the section. This is a table of recommended distances for a variety of facilities. It should be noted that these are recommendations and not requirements. If the data center doesn't meet the recommendation, the design team should assess and determine various methods of mitigation strategies that address the risk. Site selection in BICSI 002-2019 standard is a differentiator. Other data center standards either do not address this or only spend a couple of pages on site selection. So, is this important? Do you participate in this type of analysis for your client? Does the architect do it? Do you think omitting this provides value to your client? If you think this will help your client, some tools for standards compliant design are there for you. So what do you think, honey?
Do you call all your clients honey?
No, only those that deserve it.
Good point.
So let's take a look at some of the other sections in the standards in the time that we have left, so you can get an idea of what is in the standard and help decide if the 002-2019 standard will help your design career and your clients. Modules 6 and 7 are space planning and architectural. I was fortunate enough to be employed by an architectural firm as a technology designer for over a decade. I worked for many other design firms before and after that job. Working with architects is a privilege, but unless a firm specializes in data center design, your knowledge will help them come up with a better solution and do it more efficiently too. Here's a quick overview. The space planning section begins with, quote, "The capacity of a data center is based on the size of the computer room space and the capacity of the power and cooling systems per unit of computer room floor space. High-density data centers have a higher capacity of power and/or cooling per unit of computer room floor space. A couple of facility points are, and I'm summarizing, design for a defined load over a defined area. Consider future IT equipment platforms as well as current and any other unusual IT equipment. Estimate change, scalability, and implementation phases. Define budget, operational expenses, capital expenses, and total cost of ownership." The module provides a flow chart, part of which we see on screen, or alternatively, there's a 4-page checklist, again, part of which we see on screen, for space planning right after the flow chart. Architects love flow charts, as do many clients. I usually work with a checklist. Also, within the space planning section, there are a list of systems, subsystems, and components that should be included in the space planning analysis. For example, although there is a major section on electrical, the space planning section lists 3 places electrical distribution equipment will be found, including equipment typically installed in a dedicated electrical room outside the main computer area, equipment typically installed in the computer room spaces, and the third is equipment typically installed outside of the computer room.
I have a question for you.
Please go ahead.
Is the size of the space needed for the electrical equipment dependent on the size of the space needed for the data equipment?
It may be, but the standard warns us not to make that assumption. The standard points out that the space required for a power distribution system could be the same for a high-density computer room as well as one that's lower density. The most important factors are the required capacity and the level of redundancy. After space planning, the section examines data center support spaces with an emphasis on adjacencies. In other words, what needs to be next to each other. Finally, there's numerous pages on the design of the computer room, the white space, the very space that we're designing the whole facility to support. There are many requirements and recommendations in the computer room layout section. As a data center designer, I would survey your current information technology equipment and meet with your IT and network team about what will migrate into your new data center, as well as what new equipment will be added. We will determine the number of cabinets, both first day and last day, to install that equipment into. I know that you have data transport, processing, application servers, and data storage requirements, and we would begin electrical calculations based on this information. The electrical calculations will be used for mechanical requirements since power consumption produces heat. We will determine the capacity and the density of the cabinets as well as the entire computer room. With this information, we can start the design and layout of the computer room space. The standard gives requirements and recommendations about clearances, pathways for telecommunications, electrical components, and pathways for electrical conductors, pathways for mechanical systems, lighting, fire detection and suppression systems, bonding and grounding, and all other infrastructure required in a computer room. In the DC 102 class, we draw and design a computer room layout based on specific scope of work, and then we draw all the supporting spaces as team design activities. We focus on capacity and redundancy as well as the flow of equipment and personnel in the data center.
Now that sounds like fun. Challenging too.
It's cool. It really helps with conceptualizing the facility. I think it's an essential skill set for a data center designer. As mentioned, next is the architectural section. We won't go into this, but I want attendees to be aware that this information is included in the standard. Then we have the structural section. You can imagine that data centers have unique requirements for our structural engineering partners, as well as our electrical and mechanical engineers, which we'll speak about soon. This section calls out several design standards developed by the International Building Code, the Association of Civil Engineers, the Unified Facility Criteria, the UFC, which provides requirements for structures designed and constructed for the Department of Defense. The structural section addresses floor loading requirements, roof loads, seismic and wind considerations, as well as ice shard impact. This will be helpful for your Portland, Maine data center.
We do have winter.
Section 9 is the electrical systems. It's the longest section in the 002 standard, and we spent hours on this in the DC 102 class. In my opinion, this is an incredible amount of information that can help our electrical engineers in their design work. The standard states, quote, "This section will include references to other systems in this standard that, when considered and used together, will yield a strong, coordinated, and appropriate critical environment utility system." And Section 9 defines requirements solely as performance-based criteria. The purpose of such approach to defining availability classes is to uncouple them from electrical topologies and applications. Thus, to achieve a given class, a proposed design must conform to the normal, maintenance, and failure modes of operation. This provides system designers, owners, and equipment manufacturers sufficient latitude in selecting a design or a product without stifling innovation. All quotes from the manual. So unless an electrical engineer is a data center specialist, the EE will find a wealth of information here. The power consumption, density, and redundancy requirements of a data center is usually quite different than a typical electrical distribution design work. After extensive information on the requirements of the availability classes, including text, tables, and line drawings, of many possible topologies, one of which we see on screen. There is information on utility planning, including a good checklist.
What is utility planning?
It's the consideration of electrical power services to our data center in this section.
From the electric company, you just tell them to hook you up, right?
Many times it's that easy. However, our engineers should do discovery and analysis. Some of the considerations are what types of other customers are on our electrical feed, can the power company deliver the required amount of power, what's the quality of the power, can the power company provide redundancy and feed diversity required, and many other issues.
Did we do any of this during the site selection phase?
Yeah, you catch on quickly.
You did say I was a honey of a client.
Good point. All of this shows the integrated design approach of the standard. We don't want to be deep in our design phase and find out there isn't adequate power service. The standard then presents descriptions, requirements, and recommendations of individual components and subsystems of data center electrical generation and distribution. To give you an idea of what is examined, here's a quick list. Generators, automatic transfer switches, main electrical switching, UPSs, upstream and downstream distribution boards, power distribution units, automatic static transfer switches, intelligent power strips, remote power panels, busway electrical distribution, emergency power off systems, and fault current protection. The section also addresses lighting, automation and control, bonding, grounding, lightning protection, and surge protection, as well as labeling, signage, testing, and quality assurance. These are all examined and detailed. I hate to fire hose you with this cloud of words, but hopefully this will help you decide whether the BICSI 002 standard would help you. If you decide to obtain the BICSI Data Center Design Consultant DC-DC credential, you will be tested on this information. It's great to be knowledgeable about all areas of the data center since you may be the lead designer. You'll bring extra value to your client with comprehensive knowledge.
You're a DC-DC, right?
Yes, I am.
That's why I hired you.
Data centers have specific goals. They provide data services with little interruption of these services. We've talked about the strategies and the standard for achieving this. Strategies such as availability, reliability, redundancy, diversity, quality, hardening, commissioning, maintenance, safety, and scalability. I haven't mentioned efficiency yet. There's extensive information regarding energy efficient strategies specific to individual systems throughout the standards, as well as an appendix devoted entirely to design for energy efficiency. This appendix has a reference to the efficiency content of the BICSI 002-2019 to easily find this information throughout the standard. Speaking of data center efficiency, the next standard is mechanical systems.
So this is all about motors?
Well, kind of, but not really. This is about cooling, or more specifically, heat rejection.
I see. I imagine data centers make a lot of heat. Will being in Maine help?
Glad you mentioned that. It can help with the energy efficiency and reducing electrical costs a great deal. Much like the electrical section, this information can aid a mechanical engineer that doesn't focus on data centers. The criticality of removing heat and delivering cold air to compact, dense spaces is a unique challenge. As mentioned before, all good standards cross-reference and harmonize with other national and international standards. This section starts with both code and standards references, as well as clarifying terminology. This is common to most sections in the 002 standard. To give you a specific example of content, here are the recommendations for the mechanical design found in the standard. This is in addition to the requirements which reference ASHRAE thermal guidelines. The heat rejection design should consider and provide for controls for temperature and humidity at the ITE inlet, adequate filtration and ventilation, special needs of direct cooled equipment, airflow patterns for heat dissipation within the room, avoidance of recirculation of hot air and bypass of cold air to the ITE, redundant cooling systems to suit the availability class of the facility, and architectural features such as tight air and vapor barriers. This mechanical section addresses ITE equipment needs, current trends, and airborne contaminants. It gives information on cooling technologies through a series of detailed descriptions and drawings, including a variety of direct expansion, chill water plant, in-row cooling, closed cabinet cooling, and airside economizers. An airside economizer would greatly reduce the cost at your data center.
I like the sound of that. Are there any disadvantages?
Yes, it's another system to install and maintain, and it also makes fire suppression more complex. But it's a rapidly maturing technology and would likely pay for itself in a short period of time.
Is that in a standard?
Maybe you should buy a copy and find out.
Good point.
After the descriptions of the various choices in heat rejection technology, including how some of the technologies can be combined to make a robust system, the standard lays out the description of availability class as it relates to mechanical systems. This too is heavily illustrated. I'll share the description of class 3 since that's what our scenario is today. So this is a quote. The mechanical systems possess redundancy so that any system or component may be taken offline without impacting the system's ability to meet the N cooling capacity required. The level of redundancy required will be either at the system level or at the component level in order to ensure that all the mechanical components can be maintained without impacting IT operations. A failure of any element in the mechanical systems will not result in the loss of cooling capacity for the load. Single points of failure shall not exist within the overall cooling system. A minimum of N+1 components shall be provided for components with high failure rates. More than N+1 is recommended as the number of modules required to meet N increases. So I read you that to show you how the availability class aligns through the systems. There are tables in each class breaking down the systems as an overview. Some of the other issues addressed in this section are pumps, pipes, valves, as well as airflow management as it relates to hot aisle, cold aisle, equipment layout, supply air layout, and return air layout. There are other mechanical design considerations discussing humidity, altitude of the site, noise levels, and supplemental cooling. Finally, there's a recommendation about design and operation of mechanical equipment, including computer room air conditioners, CRACs, and computer room air handlers, CRAs or CRAWs, chillers, cooling towers, thermal storage, and leak detection, to name a few. Next up is the fire protection section. Like we've discussed, this can help the engineer who may not be familiar with the challenges of fire detection and suppression in data centers. The dense concentration of electrical power that produces high heat, as well as a fast velocity of air, can be problematic to designing thermal and smoke detection. Couple that with hot and/or cold air containment, often by mechanical means, and raised floor systems can cause fire suppression design issues. The standard addresses this along with many other requirements, recommendations, and descriptions of fire detection, suppression, and alarm systems. With time running out, we'll zip through the few remaining sections. I hate to do this with the security section. It's exceptional. Security section addresses physical security, not cyber network security. This is covered in another section. Along with what you would expect, such as access control and surveillance camera systems, there's content about protecting the various physical elements of the data center. As I said before, there's also a section about the disaster recovery plan. I'd like to mention one part that I'm really happy this included. There's a subsection on crime prevention through environmental design. I use these SEPTED concepts in my electronic safety and security designs and find it is a good way to contextualize the security needs for the client.
Does your class do security design?
Yes, in fact, we do it twice in the class. Next is a short section about facility, ancillary, and IP-enabled systems. This focuses on sensors, monitoring, and data aggregation from physical and network systems. This is commonly called Data Center Infrastructure Management, or DCIM. Not last, and certainly not least, is the section on telecommunications cabling, infrastructure, pathways, and spaces. I apologize for giving this short shrift. There's detailed requirements for telecom infrastructure designed by availability class. So we see the class 3 concept design, and then we also see some topology. So cabling, so we have topology strategies, description of telecommunication spaces, outside plant design considerations, telecommunications pathways, media and connector considerations, testing, and labeling.
That sounds like RCDD stuff.
Yeah, you got it. Following telecom is an information technology section, the blinky light section. Again, the network requirements are described in the availability class context. Computer room layout is revisited here, along with more media, connectors, and network transport protocols. Then we come to a really good section about commissioning. We discussed this at the start of the presentation. It's fabulous information. The last section before the 9 appendices is data center maintenance. Much of the material here is found and expanded on in the new 009 2019 standard. So that's about all I can squeeze in. I thank everyone for your time. I hope you found this helpful. If you're interested in purchasing this standard, it can be ordered from the BICSI website, www.bicsi.org, under the tab Standards. It's available in both print and electronic format. The combo of both print and electronic is a very good deal. If you're a BICSI member, you save $120 on the combo. It's also bundled in many other choices. Check it out. Well, thank you again, Dr. McCain.
You can call me Victoria.
I heard you. I'm calling you doctor to improve this presentation's gravitas.
I think you're a bit late.
Good point. And remember to join us next week for another data center standard presentation based on the life of Alexander Hamilton.
You're kidding, right?
Yeah, I'm kidding. Thanks, everyone. If you have any questions or comments, my email address is jmccain@bixby.com.